So on task number 4, the instructions are to solve the following systems of equations by any method and indicate if there is no solution or infinitely many solutions. Now this doesn't mean that all of them are going to have either no solution or many solutions, but if it doesn't have one solution, you're supposed to say which of these other two situations it is. So I'm going to do, there's actually 8 problems on this task. So I'm going to do problems 4, 5, and 6, and then the rest are for you to do. So on problem 4, if you notice, all of the variables are lined up. The x's are lined up, the y's are lined up, the equal signs, the numbers. This makes it a very easy system for solving by elimination. But to solve by elimination, we just need to get the variables. We need to get some of the coefficients to be opposite. If I were to add down right now, this would become 5x and that would become 1y. That wouldn't be helpful. I want one of them to add to 0. So I need to make the coefficients opposite by using multiplication. So here I would want to eliminate the x's. So I'm going to multiply the top equation by 3 and multiply the bottom equation by -2. That would leave the x's with 6x and -6x, which would eliminate. So as long as you multiply through everything, you haven't changed the values that make the equation true. So at the top we have 6x minus 12y equals 15, and at the bottom we have -6x plus -10y equals -4. Now it's ready to add down and the x's are eliminated, leaving -22y equals 11. And now it's very simple. I just divide by -22 and y equals -1/2. But I'm not finished yet. I still need to find out the x value that will work. So I'm going to take this and plug this back into one of the two equations. I'll use the top one. 2x minus 4 times -1/2 equals 5. -4 times -1/2 is +2. And now I just solve the equation, subtract 2 on both sides, divide by 2 on both sides. So x equals 3/2. Now, you can either work with fractions or decimals. If you had written -0.5 here and 1.5 here, that would have been fine. But in the end, also, it's best to write this as an ordered pair. Either 1.5, -0.5, or the fractions. And it's also a really good idea to check your solution in the other equation, because if it works in the other equation, then you know you're right. So just as a check, I'm going to do a little check over here. 3 times 3/2 plus 5 times -1/2 equals 2. Does it equal? Well, this is 9/2 plus -5/2, and 9, since they have the same denominator, you can add the numerators. That's 4/2, and 4/2 does in fact equal 2, so it checks. So we know this solution works in both of them. We can feel pretty assured that we came up with the right solution. Problem number 5 is set up really well for graphing. Both of them are equal to, they have output. In fact, they're even using function notation, which suggests that the intention is to graph them. Now you could set them both equal to y instead and then set them equal to each other using substitution, but I'm going to go ahead and show graphing. I know that I'm going to have to start at +15 for this on the y-axis and -6 here, so I think I'll count by 2's. And I'm going to try to make this as even as possible so that I have a fairly accurate graph. Graphing is, especially by hand, the least accurate method. So you want to try to be as regular as possible. So this is -2, -4, -6. This is +2, 4, 6, 8, 10, 12, 14, need one more for 16. So for the first one, I'm starting at 15, and I'm counting down 4. So 1, 2, 3, 4 over 1. And I should do these. Now on this axis, I don't need to count by 2, so I think I'll count by 1's. So down 4 over 1. That's right there. Down 4 over 1, down 4 over 1, down 2, 4 over 1. So that's my first line. And then this one, the second line, starts at -6, and it has a slope of 3 over 1. So that means go up 3 over 1, up 3 over 1, up 3 over 1. And I can see right there where I'm going to intersect. And luckily, this intersected at some integer values, which is another problem with graphing, is that if you're graphing and it intersects anywhere other than integer values, it's very hard to tell from the graph what the exact solution is, unless you're using a graphing calculator and it can do the hard work for you. But luckily ours did cross at an integer value. This is 3, 3 over 3 up 3. And I could even check that. If I plug 3 into this bottom equation, 3 times 3 minus 6 is 9 minus 6, which is 3. So it checks in the bottom equation. I can plug it in the top. -4 times 3 plus 15, that's -12 plus 15, which equals 3. So that checks. So we know that we did that correctly. And for the last one, number 6, this one's not really set up well for anything. I could get all the y's alone and graph it. I could bring the x over to this side and use elimination, or I could divide by 3 and use substitution. And that's what I'm going to do, just so that you see an example of substitution here. So I'm going to take this over here, and I'm going to get the y by itself, so it's ready to substitute into this equation. So dividing by 3 gets the y by itself, and we have to distribute that division. So that's 2 plus 1/3 x. And I'm going to use the fraction instead of the decimal, because if I used a decimal, I'd have to round, since that's 0.3 repeating. So this way I can use an exact number. And now I'm going to take this, I'm going to plug it in for the y in the bottom of the equation. So I'm going to rewrite that equation, 3x minus 9. So far I've written everything else the same. But now I'm going to plug 2 plus 1/3 x in where the y was, and equals 9. Because I can take the y out and put this in, and they're the same. And now I just use distributive property. I'm distributing a -9, right? Subtraction is the same thing as plus a negative, so I'm distributing a -9. So I leave the 3x alone, but when I do -9 times 2, that's -18, and -9 times 1/3 x is -3x equals 9. So our fraction even went away, which was nice. And now I combine like terms. 3x and -3x is actually 0x. Those go away. And I'm left with -18 equals 9. So this is a different situation than I've been having. I was expecting to get x equals a number, but the x is dropped out. And so now we have that strange situation where we have to interpret this -18 equals 9 situation. So we need to remember the original question when you're solving equations is what numbers will work in both equations. And so here is your answer. When the answer is, well, or another question might be when will this equation and this equation be the same? What values of x, right? But here's your answer. The answer is when -18 equals 9. And that's never true. -18 will never equal 9. So we know that there will never be a solution to this equation. So we say no solution. There's no solution. This is an untrue statement, right? This is the symbol for no solution. Now, if we had graphed it, we would have seen parallel lines. So if you wanted to check yourself and make sure that this is a parallel line situation, you could get your y's by itself. And what you would expect to find is the same slope, but different y-intercepts. And that is in fact true if you go ahead and check. So the rest of the problems on task 4 are yours to do.